Dear friends, dear colleague, welcome back to the Mangano Digital Academy. Welcome to the Essential of Digital Dentistry. In this 7th lecture of the plan phase, we will focus our attention on the scanning of natural teeth, natural abutment, and the margin. So one of the most challenging things when using intraoral scan. So let's go to the diagram that we already know very well because I present this diagram in every single lecture since the beginning of the project. Digital dentistry. Digital dentistry is made by 4 steps: data acquisition, data elaboration by means of software, production, and clinical application. In this case, when we scan a natural teeth, a natural abutment, we have to perform the final scan of our natural teeth and natural abutment, prepare it manually. We need to use an intraoral scanner, and then this data captured by means of the intraoral scanner need to be sent to the dental lab. The dental lab is equipped with a software, in this case a computer-assisted design software for the prosto, and then the dental technician can design provisional or final restoration. This final restoration are then produced by means of, usually for the final restoration in monolithic zirconia, by means of milling procedure using powerful milling unit 5-axis, and then these restorations are sintered and then delivered to the dentist for the clinical application. An innovative solution consists in printing the zirconia monolithic restoration. It is now possible, but it's very new. Usually in the state of the art is milling. So let's go to the question of this lecture: how to capture good impression for tooth supported restoration. Because we have seen that for implant supported restoration, one key element is to consider the congruence between the scan body mesh and the scan body library file. It's really key for giving the possibility to the dental technician to model well and to avoid mismatches or in the position of the implant among the real actual position of the implant and the virtual position in the computer assisted design software. But with natural teeth is different. With natural teeth is more tricky, because we have a margin that has been prepared manually and is not so precise like a library. We don't have any library, so the dental technician needs to draw, to design, to identify first the margin line, and then you need to design it manually inside the computer assisted design software. It is not easy, particularly if we did not capture as dentists well this margin. So it's very important to properly handle with tissues. It's very important to avoid any error during the final impression. How does it work? When we get to the final impression, we need to scan for how I proceed usually. This is the workflow. I scan the master model with the temporaries in position, functionalize it, because this gives me a lot of information about the occlusion. Then I scan the antagonist and the bite. The dental technician will model the final restoration according to the information, vertical information given by the bite, but also given by the temporaries. It cannot, model too much outside the temporaries, because it will likely, or she will likely to have pre-contacts. So the temporaries in position are very important. Then what I do? Then I usually cut the temporaries and I scan the master model with other temporaries, so with the abutment, with the natural abutment, with the prepared teeth. Then I cut the margin areas only and I insert the retraction code, 1 or 2 retraction code depending by the case, depending by the kind of margin that we have, because the margin can be subgingival in some cases, for example with dyschromic teeth, with reconstructed teeth, but they can be in the sulcus or a little bit even supragingival in the case, for example, of some kind of reconstruction, when we don't have this chromic abutment, when we have, for example, lingual or palatal margin. And then what I have to do is to remove the retraction code and very fast rescan only the area of the margins. And if I have a lot of prepared teeth, a lot of abutment, then I can block the surface one and proceed with the surface of the other one in order not to rescan it, because it's very important to proceed fast, because the sulcus collapses over the margin, over the preparation quite fast. So we have probably 1, 2, 3 seconds to capture the entire margin Otherwise, if we don't use this time, we will probably likely to lose the definition of the margin. And then we have to perfect the margin line, perfect the whole model and export as a polygon file or a standard tessellation language file in order to send the information to the dental technician. The dental technician, first things you need to do margin line design. And the identification of the margin by the dental technician inside a computer-assisted design software strongly depends by the quality of the margin in our scan. So if we didn't capture very well the margin, if we didn't capture enough, this structure, then the dental technician cannot design it properly. And then after this, after the identification of the margin line, that is key for the marginal closure of the restoration, so for the success of the restoration in the mid and long term, then the dental technician can design the restoration, and then it's a work of art, you understand. You can design the model, export everything for milling, for printing. We can mill, for example, or print the model, but usually the model is printed and the restoration is milled. When we work, we usually mill the replicas in a hard material before to go for the zirconia, in order to have an appointment for checking the fit and adaptation of the replicas, not only on the model but also intraorally. And after we have checked intraorally for the monolithic, for example, that the adaptation is perfect on the margin, that we don't have problem, we don't have any gap, and also the interproximal contact point and the occlusion are perfect, then we can say to the dental technician, okay, I like this design, let's proceed with the zirconia. We can mill the zirconia and we can sinter the zirconia and deliver the final crown after characterization. So this is how I proceed, and I wanted to show you one single case, CS3700. 3 prepared teeth. As you can see, the margin are clearly visible after the perfection of the scan by means of the software, because we have respected all the steps. So these are the steps. First, I capture the master model with the temporaries, then the antagonist, then the bite. Then I cut the temporaries and I capture the master model without the temporaries. So I capture the position of the abutment of the natural teeth prepared, and also the adjacent teeth that are key for the proximal contact point. Then the final point, point number 5, is cut only the margin area around this abutment, around this prepared teeth, insert the retraction cord, 1 or 2 cord depending by the clinical indication, and then remove the retraction cord fast and rescan only that area, only the area of the margins, in order to capture the margin and to capture also an area over the margin, in order to see exactly the definition of the margin. And then I can perfect the scan at a high resolution and export the scan in different format, in color or without color. Usually the dental technician works without color, but in some cases when there's some bleeding, also to export the file in a polygon format with color can be helpful for the dental technician as well. So let's proceed phase by phase. The first things that I do with the temporaries in situ, I scan the master model with the temporaries, because I want the dental technician to add the information about the functionalized temporaries. This because I trust the occlusion captured by the intraoral scanner, but I want to verify it with the temporaries in function. Then the second step is to capture the antagonist arch, of course, and the third step is to capture the bite. We need to capture the bite. If we scan the whole arch, we need to capture at least 2 bites in the right side and 2 bites in the left side in order to give more information to the scanner. It's very important that the patient close well in maximum intercuspation, not too much, but the patient doesn't have to move during this registration, and sometimes it's difficult. And this is why I scan the first scan with the temporaries in situ, because I want to give the limit of the anatomy of the temporaries to my dental technician. Is an additional information he can open and close in the, and he can visualize or not in the computer-assisted design software, and this is very helpful for the final modeling of the final restoration. But here we have scanned the bite. If the arch is a demi-arch only for a posterior restoration, then I can scan half the arch. It's accurate enough. It's not needed to scan the whole model. Anyway, we need to scan also on the contralateral side and verify the occlusion visually and inspective an inspection also intraorally is very much appreciated in this case, because the capture of the bite is very key, is very important. And then when I have removed the temporaries, I have cleaned very well all the abutments, still I didn't insert the crown, the retraction cord. I scan the abutment as they are. And as you can see, I don't have a lot of details of the margin, because I don't care about the margin now. I just care about the position of the natural teeth and the abutment and the prepared teeth. I just care about the future interproximal contact point of my restoration. So I focus on the neighboring teeth, for example. I want to complete my model with the perfect position of the abutment. But then, point number 5, it's very important after point number 4, I need to cut the model, and I cut it accordingly. So I use the tools inside the software to cut, to remove only the marginal area. So I remove a part of the margins and a part of the gingiva around. And then I'm ready to place the retraction cord, in this case 1 retraction cord per abutment, per tooth, per prepared tooth, and then to remove the cord and capture the detail of the margin with more detail visible, with more subgingival data. I mean, in the sulcus we can read very well. And this is what we get after we have removed the retraction cord and we have rescanned the margin areoli. As you can see, it's totally different from the previous scan. Here we can clearly visualize the margin of this chamfer preparation. And it's really very nice. We can transmit all this information to the dental technician. And let me say that after 5 seconds after I have removed the retraction cord, then the margin collapses. The gingiva, the sulcus collapse over the margin, and I don't see the margin anymore. So I need to be fast. And how to be fast? We are talking about 3 abutments. Very easy. We use the tools inside the software. We scan first 1 prepared tooth, then we block the surface, then we remove the cord in the other, we scan the other, then we block the surface, then we remove the cord in the 3rd one, and we scan the 3rd one. There's no risk to superimpose, there's no risk to overlap the already scanned prepared teeth. There's no risk to avoid data, there's no risk to jeopardize our final results, thanks to these powerful tools inside the software of the intraoral scanner. In particular, this is the ScanFlow software from Carestream Dental. So here we have all the details needed, and then we need to perfect the scans. We need to perfect the scan, the image refinement at the highest resolution. It's very important. If we talk about implants, maybe we can avoid to do it. If we talk about orthodontics, maybe we can avoid to do it, but why not? But if we talk about natural teeth, please, when you refine the image, please do it at the highest possible resolution, because the literature and paper from Robert Nedelko and colleagues, they have clearly identified that the resolution of acquisition is key for the dental technician in the visualization of the margin. And the dental technician can visualize the margin, and then after the dental technician can design the margin line perfectly. But if the dental technician doesn't visualize the margin, how can he or she design the margin line properly? Then it becomes an act of faith. Then the dental technician needs to try to imagine where the margin line is and define and design it and draw it. But it's a disaster, because then we will have a lack of clinical precision, a lack of adaptation, and probably some micro gap there. So we need to perfect the image refinement at the highest resolution possible. We are talking about 300,000, 400,000 triangles per each model in this case, and this is what we get. Perfected high resolution images are ready to export. I see everything very well. Everything is very clear, no issues, we can proceed fast, send the information to the dental technician, excellent margin line visibility. If we see it, the dental technician will likely to see it, and no mistakes. So the question is, if we don't see it well, should we send this file to the dental technician? And the answer is no. We need to capture the scan again, cut and try again to capture it. Avoid bleeding, for example. Be fast. Ask the help of the assistant. The assistant must be very helpful in this phase, because the dentist scan and the assistant remove the retraction cord, and everything should be very fast. And also, the temporary phase is key for the maintenance of soft tissues in a very good heal, in a very good condition, stable, without any bleeding, without any sufferance, without any problem, because if the for example, the temporaries are not very well designed, they are not polished enough, they are rough, if there is an excess of cement, all these aspects, they can create problem for the final impression. For example, some kind of bleeding, and we don't want bleeding because we need to prepare with the temporaries the tissue for the final impression. There's nothing new. We always did it with a conventional material. We need to repeat what we already learned from the past, what we have already learned from the masters of Prosto. We don't need to change nothing. We are using other tools, but the principles are always the same. We need to allow the dental technician to see the margin. We need to allow the dental technician to design the margin well. If we don't transfer the correct information, the dental technician will likely to fail in the design of the margin. And this will finally result in a micro gap or problems in the adaptation of the coping of the framework or the monolithic crown as well. So it's a problem. So this is our information. We can send it to the dental technician together with the temporaries and without the temporaries, with the final impression. And then we have the plan with the EXOCAD, the margin line design, of course, by the dental technician. The dental technician must be extremely careful when designing the margin line, because really it should be something perfect, checked in all the possible, from all the possible perspective, all the possible views, and then the dental technician can create the model and can model the restoration accordingly. In this case, the design of the restoration 3 copings, because in this area we want to create, we want to manufacture 3 copings in zirconia, and then to perform a restoration that are veneered on, because we want the maximum aesthetic results. So this is the idea here in EXOCAD. So the dental technician can design the copings in order to have a perfect adaptation on the margin line, and these are the copings ready for the milling of the try-in of the replicas. And this replica must be checked on the 3D printed model, split cast, but also inside the mouth of the patient. A double check is necessary, particularly in the mouth of the patient, because if there is some mismatch, if there is some gap between the coping and the abutment in mouth, we need to rescan, we need to start all over again, because we are not satisfied by the final result. This is the model creator inside the EXOCAD. The model is key in this case. If we use copings, if we use framework, we cannot proceed model free, because the dental technician really needs a model to add the ceramic over these copings to make the artistic work. Is mandatory. In the case of monolithic restoration, this is a phase that can be skipped. There's no need for a model. Most of the time we can proceed full digital without any model, so model free. These are the split cast over the polygon file in the EXOCAD software. And these are some beautiful views, some nice view. The dental technician can check the adaptation of the copings over the preparation. If the preparation are and the margin are very well visible, everything works very well, and it's fantastic. And after it, another case similar, as you can see, once again, we need to see the margin. If we see the margin, even in case of little bleeding, we are satisfied. We need to control the margin with color and without color, because most of the time the dental technician model without the color as an STL file. But also we need to transfer the temporaries, as I told you before, because the temporaries are really very important. They give us information about the function very much, and this information integrate the function, the information that we get from the bite, the capture of the 2 bites on the right side and 2 bites on the left side. The visibility of the margin anyway is key in all the different images, because it helps the dental technician to design the margin line correctly and perfectly inside the software. This step takes a lot of time. The margin must be designed well. The dental technician must watch the teeth in a very big screen in order to design the margin line at best. And after this, all the abutment or the natural teeth prepared have been identified with a proper margin, and then the design of the restoration start. And after the margin line has been designed, everything is something like artistic. Its function is aesthetic, but has nothing to do with the biology, because the biology is the margin line design. That makes all the difference for the long-term survival of the restoration. So this is the design of the restoration and the model builder, all the split cast. We can print the model with the split cast. that can be removed or not removed by the model. And here the design of the monolithic single crown. In this case we opted for monolithic because it's a huge kind of restoration, no need for copings. We can work with color, with translucent zirconia very well now. In some cases also in the anterior it's possible to use lithium disilicate, monolithic. In this case we work with zirconia. And here again another picture. With these tools, with this software, we can really pre-visualize in 3D how the treatment will be, how the crown will fit, how the abutment is, the emergence profile, everything. We can really plan and we can watch in detail, for example, the thickness of the restoration in relation of the abutment. It's very important also to foresee any possible complication and to avoid any possible complication. And then we go to the make phase. We have this software provided by DigiShape, by Roland. It's the MILLBOX software. I love it particularly because it's very easy to use. I can mill my own replica fully in office. It's very easy, really. The nesting, the procedure of the nesting is very fast and easy and controlled, and everything works very smooth. A dentist can do it without any issue. I prepare my nesting, I prepare everything for the milling, and in a time compressed between 1 or 2 hours in this case, because we are talking about many restorations, we can mill everything, all the copings, all the framework, all the monolithic bridges, the monolithic crowns. And the milling unit is very reliable, very fast, very accurate, very precise, absolutely fantastic. I love the Roland milling unit. We can adapt all the different strategies for the different tools in order to avoid undercuts, in order to minimize the effect of anatomies. For example, we can choose our tools, we can choose our drills, the sequence of our drills. We can also familiarize, and we can also customize our steps, our treatment, the way the drills the way the bars will work in this case for the preparation of our replicas. And this is our DWX 52D by DigiShape by Roland that we use in our clinic with the disc of replicas. And these replicas are very important because we can use these replicas to check the adaptation on the model first and then in mouth. It's important, but at the same time we need to print our model, and our model are usually printed using the powerful DWS 3500 PD from the DWS system, an Italian company that fabricate excellent printer. And in this case there's the whole set of file we can print all together, and it's also very easy to print with this machine. It doesn't take a lot of time, it's also fast. You save a lot of time and material, and the accuracy is amazing because the printer is really high quality, very professional. You need to clean with alcohol, you need to of course prepare the model for the curing, because there's a post process that is based on curing. This resin is Precisa RD097, super accurate. And then we have a highly accurate model, we have highly accurate copings, highly accurate frame, or highly accurate replicas of the monolithic crown. We tried to find if there's some problem on the model. On the model everything fit very well, on the split cast, on the model itself. And then we go in the mouth because we need to verify clinically if there's some mistake during the workflow. And if there are no mistakes in the workflow, then we can finalize the case, because this checking of the fit is very important, but we can finalize the case. And we finalize both cases like I have presented here. Everything worked very well, it's very successful, and we are very happy. The patient is happy, and the final result is very satisfactory from both sides, from the dental perspective, from the dentist perspective, from the technician perspective, and also from the patient perspective, with a perfect aesthetic integration. This is our final goal: function, aesthetic, and biology. We don't need to forget the principles of prosthodontics, because the principles are always the same. We have modern tools, we have modern devices, we have modern technologies. The technology is helping us, but we don't have to forget the principles taught by the masters of prosthodontics for around 50 years, because the principles are always there and they are the main focus, the main target of our therapy, the result. So this is very important. This is something that we don't have to forget about, and thank you very much for your kind attention. and I hope you liked this lecture, and I hope these tips and tricks will be useful for you in order to improve your skill, improve your ability to and to become a very excellent and successful digital dentist. Thank you.